Welcome to a new discussion with Andrea Oldofredi regarding Bohm and the evolution of his ontological reflections in the 1950s. This will be sort of a historical review and also a quite philosophical discussion, and I hope you enjoy it. The best thing for us to do, if we want to sort of give an overview of this paper, is maybe to start talking about David Bohm. If you want to give a brief overview of who that person is, and then also what his particular take on quantum mechanics is.
Yes, that's a very interesting question, and the answer is very complex because Bohm himself is a very complex author in its own right, because he not only is an excellent physicist who gave important contribution to theoretical physics, besides also the foundations of quantum mechanics, but he also was a very deep thinker, philosopher of science, and he was really engaged with philosophy, I would say also in its continental aspect. He knew very well Marx, Engels' writings. He studied Hegel. So he was very conscious about what was going on also on the political side of things. And he had a very complex personality as well. So David Bohm is mostly known for his contribution to the interpretation of the formalism of quantum mechanics, and he provided in 1952 a couple of papers in which he suggested what he called hidden variable interpretation of quantum mechanics. Basically, he provided quantum mechanics with an ontology of particles and reinterpreted the Schrödinger equation, where the psi function, in his view, is to be interpreted as a physical field, and this field is guiding the motion of real particles moving in space, and they made up matter. And also, of course, the wave function has the role of governing the distribution of this particle in space. But what is really interesting about Bohm is that with these papers, he just wanted to provide an argument, just showing that it was possible to provide an alternative view, an alternative interpretation to the quantum mechanical formalism. And because this is not very well known, but in the 60s, in the 70s, and then finally in the 90s, he provided very different interpretation of his own work on hidden variables, because we now tend to discuss in the philosophical literature, but also in the foundational literature, Bohm as a unique theory which has been developed by Bohm and then by other people like John Bell and Goldstein-Zangi, especially in the 90s and early 2000s. But we, as a community, try to see this theory as a static entity, which is not, if you read with attention Bohm's paper, because he was very clear in saying that he only showed that an alternative interpretation with respect to Bohr's and Heisenberg ideas were possible, and that he continued to modify his theory during the decades that he worked really intensely on this interpretation in the 50s, and then after several I would say negative and biased a reception of his theory, he kind of forgot. He preferred to not work on it anymore, and he was rediscovered in the 70s by some students of his in London, Chris Dewdney in particular, and then he began to work on this theory again with Basil Healy. Healy was collaborator of a strict collaborator of Bohm in London, and they did very interesting work from mid-70s to the early 90s. Instead, if we want to talk about the person David Bohm, he has a very interesting life. Interesting does not necessarily mean something positive, because he was victim. Yes, he was. His history, however, his story is quite interesting from a philosophical and sociological perspective, because it gives us the an interesting, snapshot or screenshot of that situation. He photographed very well what was going on politically and aftermath of the Second World War in America. He was victim of McCarthyism, and he had to go to Brazil, and he lost his American citizenship, if I'm not wrong. Then he was able to go to Israel for a couple of years, and then he moved to the UK, first in Bristol and then in London, where he basically proceeded with his career until his death in October 1992. So he had a very, very complicated life, very strong political opinions. He was a convinced Marxist up to the mid 50s, and then he started to look for something else. He had a very interesting intellectual relationship with Krishnamurti. He wanted to explore other sides of human reasoning, and he tried to understand also different philosophies, not only Western thoughts, Western thinkers, and it's very difficult to summarize what has been David Bohm in a few minutes, but I suggest everyone to read his biography, which has been written by Olival Freire Jr. He is a historian of physics working at the Federal University of Bahia, Brazil. And the book is very recent. It has been published, if I'm not wrong, in 2019 by Springer.
Okay.
So
okay.
The name of the book is David Bohm, a life dedicated to quantum foundation, something like that. I am very bad.
We can link it. We can link it in the description.
Yes.
So people can see it.
And also, if we want to understand more the political things that happened in the early 50s to Bohm and to his interpretation, the reception of his interpretation, then Freire wrote another book, which is called The Quantum Dissidents, and this is a real masterpiece. Only one part of the book is devoted to Bohm, because the other dissident is Hugh Everett, and also people interested in Hugh Everett work can find a lot of historical documents and a very careful reconstruction of what happened in the 50s, also to the relative state interpretation of quantum mechanics.
Were there any trends that related to the events in the life of Bohm and the work that he was doing as well? So particularly if we're talking about his interpretation of quantum mechanics and sort of the well, reinvigorated interest, let's say, for further development of his theory. Did that somehow coincide with him relocating to a different place, or other life events? Do you know that?
I would the answer I would say uh, probably or likely not, because he worked firstly in 1951 after the publication of his textbook on quantum mechanics, which is called Quantum Theory. In this book, David Bohm was presenting in a very clear manner, if you wish, the standard interpretation of quantum mechanics. And for a short period of time, Bohm was kind of, I wouldn't say in agreement with Bohr's perspective on quantum mechanics, but it was not opposed to it. And then after several readings that he made and several conversations with Einstein, he developed what is called a hidden variable interpretation of quantum mechanics in 1951, and this paper appeared in January 1952. Then, in exactly this period of time, he had to move from Princeton to Sao Paulo in Brazil. And then, while during his time in Brazil, he worked and developed the theory in some more detail. He published a very interesting paper in 1953 about the origin of the Born's rule in his pilot wave theory. He wrote also in 1955 a couple of papers about the interpretation of spin in his hidden variable theory. He used the Pauli equation as the foundation of dynamics and not the Schrödinger equation, as he did in 1952. And then he worked to his, I would say, one of his most interesting books that appeared in 1957, which is called Causality and Chance in Modern Physics. During this period from 1951 until 1957, he moved from Princeton to Sao Paulo and then to Israel, and then he was able to go back to the UK around more or less the publication of Causality and Chance. And then he didn't work too much on the hidden variable theory until the mid 70s, as I told you. Of course, you can find papers of Bohm discussing the hidden variable interpretation in the 60s, but he, let's say, actively developed the theory from mid 70s until the early 90s. So I wouldn't say that his personal journey had to had an impact on the ideas on about the pilot wave theory. Let's say this way.
Okay, but I take it then that most of the criticism he received was in the 50s regarding the suggested theory that he laid out, and that was somehow intrinsically related to him stepping away from the theory for a couple of decades to then resume it. Is that a fair assessment or a summary?
Yeah, this is a fair summary.
Okay.
I would say that the criticism to the pilot wave theory is still ongoing to the present day. So actually never ended. But what is really interesting from a philosophical perspective and also from a sociological point of view is that the question that and the criticism that today we usually see against Bohm's theory was basically replied by Bohm himself in the 50s. So I would say there are two kinds of criticism. One is a very interesting and constructive, So many physicists complain about the, I would say, possible extension of the Broglie-Bohm theory to a relativistic version of the theory. So the main criticism is that you don't seem to have a very compelling extension to a relativistic regime of your theory. And this is a very constructive criticism, a very interesting thing to say, because not only on the one end it makes you think about how to extend this approach to relativity, but also on the other hand can be useful to think about what does it mean really to have a relativistic quantum theory, because there are multiple answers. So what is a relativistic quantum theory? It's just a postulation of a theory which respect the requirements of both quantum mechanics and relativity. I would say no, because then you have to explain how non-locality emerged in non-local theory. And then we can go and further discuss what is the meaning of non-locality in various quantum theories. So this objection about the relativistic extension is very interesting, because it makes you think about very interesting and important topics in quantum foundation. On the other hand, you have people dismissing the theory for wrong reasons. Like, we know that the world is not deterministic, so this theory is deterministic, therefore is wrong. Or this is a hidden variable theory. We know that there are a lot of no-go theorem forbidding the existence of hidden variable theory. Therefore, Bohm's theory is false. Others still invoke Bell's theorem, saying that like the epitaph of every hidden variable theory. But this is, of course, very, very incorrect. These kind of criticism are still very, very common. And if you read with attention Bohm's paper, you will find all the answer to this objection. In particular, what is very interesting, if I may continue the answer, or
sure, absolutely, yes,
is the issue about determinism, because Bohm was not a physicist who wanted to restore a deterministic view of physics. Instead, he was pretty much against any kind of extreme reductionism. He was very open also to stochastic theories, where the stochasticity is a fundamental feature of nature. So to say that Bohm was attached to determinism is to say something historically inaccurate and wrong. Yes, determinism is a feature of Bohm's theory, but to restore determinism as a philosophical doctrine, it was not in Bohm's agenda, let's say.
Okay, so if we stick or linger a little bit longer on some of the criticisms that were received in the 50s, I think quite a few of them were quite harsh. Like some of them I think I paraphrased from your paper, and then some I found otherwise. Like Niels Bohr said it was very foolish. Rosenfeld said it was very ingenious but basically wrong. Oppenheimer said it was juvenile deviationism.
Yes.
Einstein said it was a physical fairy tale for children, etc. So would you mind maybe painting a picture of what like set of events, or would you like to analyze why this harsh criticism was raised of the theory at the time? Was there what do you think were the driving forces behind that? If the criticism was not based on let's say the theoretical shortcomings of the model in the context of generalizing it to a relativistic model, then why do you think these kind of criticisms arose?
Yeah, that's a very interesting question. In the paper that I recently published about the reception of Bohm's theory, that appeared on the European Physical Journal Age in October 2023, I tried to explain historically what was going on with Bohm's theory. On the one end, at the beginning, if we consider the correspondence between Pauli and Bohm, which is a very interesting document indeed, we can notice that Pauli simply dismissed Bohm's theory, defining it just a repetition of de Broglie, Louis de Broglie work on pilot theories that was presented at the 5th Solvay Congress in 1927. It is very well known in the history of physics that Pauli had interesting objection against this theory. And the usual narrative is that after these criticisms, de Broglie decided not to work on the pilot theory anymore. This is just part of the story because de Broglie, Louis de Broglie received criticism also from Kramers, and he himself was not happy with his theory, and this is explicitly stated in a book he wrote in the 30s and in another paper published after the Solvay Congress. So let's say that Pauli's objection to de Broglie theory was not I would say was not so important as many historians or philosophers tend to say. So it was certainly important for de Broglie, but there are other motivations that led him to dismiss or not work on the pilot theory in the subsequent years. So Pauli thought of Bohm's theory as a simple repetition of what he calls the Broglie old errors. And he replied to Bohm saying exactly the same thing he said to de Broglie in 1927. The point is that in the 1952 papers, Bohm was able to provide a full answer to Pauli's criticism, developing a full theory of measurement in terms of particles moving in space. And for the interested readers, this can be found in the second part of Bohm's paper. If we want, we can link also this paper in the description of the video. So basically, Bohm said, I can answer all your criticism to the Broglie theory. What we can see from the historical documents is that it took a while until Pauli actually read with attention Bohm's paper. But eventually, in December 1951, he recognized the logical internal coherence of Bohm theory and say, I have no longer the possibility to claim that your theory is internally inconsistent. However, he made a criticism that the story is only partial because you cannot extend this picture to quantum field theory and relativity. I would say that Pauli was not interested anymore in the pilot wave theory because he was into cutting edge research in quantum field theory at the time. So he did not want to waste his time reading Bohm's paper that he considered kind of a dead program, dead research program. So I think that Pauli criticism are, the second part of Pauli criticism about relativistic extension are fair criticism to Bohm's theory. Of course, in the first exchanges where he appealed to his own objection or to von Neumann theorem, then one can deduce that he did not engage seriously with Bohm's paper. Especially the thing of the von Neumann theorem is particularly interesting because von Neumann himself admitted the consistency of Bohm's theory, so he said that his own theorem does not apply to Bohm's theory. So basically what was going on is that Pauli was not was, in my opinion, negatively biased because he had strong negative opinions about the Broglie theory. But reading Bohm's paper, he had to realize that his old objections were answered, but he was not convinced by the Bohm's proposal, let's say, because it's mainly non-relativistic. A different story can be told for Rosenfeld. Rosenfeld criticized Bohm from a philosophical perspective because he was a very close collaborator of Niels Bohr, and he really supported the complementarity perspective on quantum mechanics, the philosophy of complementarity. So he said that, and he said a very curious thing, basically saying that there is no question about, or even a debate about what is the meaning of quantum formalism, because the philosophy of complementarity, the point of view of Niels Bohr, was perfectly consistent, and this is what quantum mechanics tells us about the world. So there is no question about the interpretation of a theory. So basically, Bohm had to face very strong negative opinions about his theory, and I would say that of course this negative reception alongside with his personal I would say his personal trajectory, let's say, in his neutral way, did not make him happy with how the physics community reacted to his theory, and he decided to just say, okay, let's put the theory, this proposal and kind of stand by, or let me work on some other thing.
Okay. The latter half of the paper is devoted to sort of the evolution of Bohm's philosophical reflections. Would you mind summarizing briefly? I know that's a big question that I'm throwing your way now, but would you mind summarizing briefly sort of how that evolved through the years?
Yes. This is very difficult because the philosophical aspects of David Bohm works are very complex. But let's say, let me say the following. So we can define somehow Bohm as scientific realist. It was a naturalist philosopher, so basically the reality that we experience is made of material stuff, and everything should be explained in terms of object and in space-time, causally interacting, and without any additional elements. So everything should be explained in scientific terms, if you wish. And this is a doctrine that we find also in Engels' writing and Marx and Engels' writings. So there is evidence that he knew this text, and he drew inspiration from them. So we can basically say that he wanted to provide with his theory a more realist perspective on quantum mechanics. But the very notion of reality is not exhausted by our scientific theory. So he said that we can know a tiny fraction of reality through the lenses of our scientific theories. So we have to be careful in saying that this is real, meaning that reality is reflected one-to-one by the axiom or the ontology of a given theory. He said that we can grasp some pattern, we can grasp some objective feature of reality, and of course we can be realist about that. And he was not happy with the positivist attitude behind Bohr and Heisenberg perspectives of quantum theories, and he wanted to provide an alternative view, because from arguments taken from the history of physics, he said that positivism is not generally a good guide in order to build scientific theories, and one major failure of positivism has been denying the existence of atoms at the beginning of the 20th century. This is the example that Bohm uses against positivism. Of course, we have to be careful in attaching labels to Bohr and Heisenberg. There are historians of science that would disagree here strongly with Bohm, saying that it's not true that Niels Bohr was an instrumentalist or a positivist. Don Howard's work on the philosophy of Niels Bohr point this out very clearly. And also Heisenberg, it seems that he really evolved from the positivism or the empiricism that he endorsed in the 20s. In fact, Heisenberg even said that positivism is a silly philosophical doctrine in the 50s. So Heisenberg has a very complex philosophical position and a philosophical trajectory. So we have to be careful in saying, okay, these two guys are positivists. But this is what emerges from Bohm's 1952 papers. So he wanted to provide different stories for quantum mechanics, saying that what measurement result can be explained not only realistically but also causally. The notion of causality is central in Bohm's writing, because also causality is a way in order to relate facts, relate phenomena that we see. So what scientific theory should do is to individuate the relevant facts and explain them causally. So causality is the real thing for Bohm, even more than realism and, of course, determinism, because many philosophers, philosopher of physics, seems to conflate the notion of causality with determinism. And for Bohm, this is a mistake, and he always said, only if you have a very strong reductionist view, then the two notions of causality and determinism will coincide. But if we think about a possibility to avoid complete reductionism, then determinism is just a feature of a particular layer of reality. But we cannot say that reality in itself is deterministic, completely deterministic. And the main difference between causality and determinism can be stated as follows. On the one hand, causality allows you to change initial condition. If you change the initial condition, then you can predict a different outcome, or you can predict a different effect. Instead, if you have complete determinism, you don't have this option to even imagine a different initial condition. And he also said a very interesting thing, which is not very often mentioned in discussion about Bohm's philosophy, that also stochastic theory can be causal, because he said, starting from a given set of initial condition, then it's true that the final state is not related one-to-one with the initial state, but you have an interval of possibilities, and whatever final state you will find out, we know that it is causally related with this initial condition. So causality and causal laws are the fundamental requirement for Bohm in order to be a meaningful scientific theory. And related to this, we have the very interesting critique to what he called mechanistic philosophy. So the philosophical idea that maybe nowadays we call reductionism, that everything has to be explained by a finite number of notions and scientific laws, and from these basic ingredients we have to explain every aspect of reality at every level or at every scale. He said, from the history of physics we can say that physics in particular is a never-ending discipline, so we still discover layers after layers of reality, and if we stick to the history of the discipline, there is no reason to postulate that there will be a final level from which we can draw deduction about every aspect of reality. And also he said, and we can call this sort of metaphysical attitude infinitism. So he said there are infinite levels of reality, and if we cannot say that there is a bottom ground, a bottom level, then of course we cannot say that reality is completely determined. Of course you can keep causality, you can keep determinism and specific levels, but of course you cannot say that reality is completely determined by this fundamental or bottom or ground level, call it as you prefer. Yes, in the 50s he tried to develop this infinity of levels, pictures of reality, providing a kind of complex philosophy behind it, keeping causality and preserving realism. Of course, saying what realism should mean. So we have to be careful in saying that he was a realist. Yes, he was a realist in the sense that scientific theory grasped objective feature of reality. So we shouldn't conflate the notion of reality with what our best theory tells us about reality. I know
When
that
we say,
I'm sorry.
yeah, please go ahead.
No.
Please go ahead.
I understand that is philosophy is can be counterintuitive. But another criticism that comes to mind is that he wanted to restore a classical picture of the world. This is completely out of track if you take the time to read Bohm's philosophical production, because it is the complete opposite. So Bohm was completely open-minded to new ideas, new ontologies, new paths. Also about physical theories, he also conceived possible ways to modify his theory at subquantum levels. I can say that maybe for someone not expert on Bohm's philosophy, what I'm saying sounds sort of weird, but it has a very strong internal coherence.
Would you mind, so this is the question I was going to ask before. When we're talking about sort of an infinite structure to reality or infinite layers of truth, do we mean that in the sense that that they are really layers on top of layers? Or are we saying that you can approach it with local theories from different perspectives? Because you could make the case that you have theories of the world that are all local in a sense, and that you're approaching the world through different lenses or from different angles, let's say, and arrive at different a different characterization of reality is from that perspective. But that's not what you're saying, if I'm understanding this correctly. You're saying that, first of all, are you saying that there is one true perspective to look at the world through, and that there is an infinite layer of more profound truths to be discovered looking through that direction? Or are you saying that the latter half of that is correct, and that you can arrive at different layers that are more profound regardless of what perspective you look at the world through, if that question makes sense?
Actually, it makes a lot of sense, and the answer is not trivial. Now, if you ask whether there is an objective or absolute perspective about reality, or there is relativism or relationalism, then I would say, for my understanding of Bohm, he says that science is about what is objective about reality. So every subject, every person should agree on that. So science founds and discover objective feature of the external reality. We know that there are approaches to quantum foundation in which this point of view is put in discussion, like for instance in Carlo Rovelli's Relational Quantum Mechanics, where he said that different observers provides different but equally correct and non-contradictory statements about the world. But Bohm said, at least as far as I can understand his writing, that science is about what is objective. So we are not approaching the same reality from different angles, let's say. But what he wants to say is that a scientific theory shouldn't be applied to every scale and to every phenomenon. So every scientific theory comes with a specific domain of application. So the point, and he said that explicitly in 1953, replying to some objection coming from a Japanese physicist, Takehiko Takabayashi. In this paper, that we may also link in the description of the video, Bohm explained very well what's the problem with this sort of reductionism. He said, if you apply the kind of Newtonian mechanical perspective to every layer of reality, from the macroscopic regime to the cosmic regime to the microscopic regime, of course you will end up with disastrous consequence. But the problem, says Bohm, is not with the theory itself, is how we apply the theory. So when the law of Newtonian mechanics breaks down, then we understand when the theory is not an accurate description of reality anymore. So within a certain specific range, then this theory is telling us some truth about reality. But then we have to discover more fundamental causal structure, more fundamental laws that are valid at specific level, let's say quantum mechanics. And then Bohm goes on saying there will be another level, what he called subquantum level, in which quantum mechanics will be just a statistical theory, because we know that what we observe at quantum mechanical level is just the average path of subquantum mechanical particles or entities or whatever you like. So he thinks that there are layers of theories, and these different layers of theories describe a definite domain of reality. And of course there are limiting procedure and relationship between theories. But of course, I would say is infinitism is not about a sort of a relative or perspectival sort of realism. If this answers your question.
Yes, it does. We're also almost also out of time, so we have a couple of minutes left.
Okay.
That's fine.
I talk too much.
That's fine. I just want to ask if you have any final conclusions that you want to raise before we close on the paper or on your research in general that you think would be worthwhile to share with the community.
Yes, I have 2 points, if I may. Sure. So the first one is to underline the importance of historical research. Also, if you are doing philosophy of quantum mechanics, because sometimes criticism or discussion that we are having today basically just repetition of very old mistakes, facts that we know are not true. For instance, if we keep repeating that Bell's theorem disprove Bohm's theory, we are saying something wrong, and we should by now have learned how or what Bell thought about Bohm's theory. He was a very very enthusiastic about this theory. But this is one example. If you think what people think about Everettian quantum mechanics today, the majority of them will say the many worlds theory. But there are so many historical documents that say that that highlight how much Hugh Everett really disliked this many worlds interpretation of quantum mechanics. So it is a huge mistake to equate the many worlds interpretation with Everett's own perspective of quantum mechanics. So historical knowledge really clarifies a lot of conceptual confusions and can really help people understanding what a specific author had in mind, what a specific theory tells us about the world, and the specific interpretation, the goals of this particular physicist, the motivation that led some scientists to propose a given interpretation of quantum mechanics. For instance, it's not uncommon to see or read that someone said that the pilot wave theory has been invented or created to solve the measurement problem. But when de Broglie firstly introduced the pilot wave theory, there was not even quantum mechanics as we know it today. So of course, he was not proposing the theory to solve the quantum measurement problem. So the first thing I want to say is that so historical knowledge, knowledge about how ideas were presented, how ideas emerged, can really help people avoid systematic errors, and this can be really interesting for future debates, because we can start from something at least correct. So, and the second point, if I may say something about my current research.
Sure, please do.
I am editing a volume about the pilot wave theory that will be published this year in autumn by Oxford University Press. The book is called Guiding Waves in Quantum Mechanics, 100 Years of the Broglie-Bohm pilot wave theory. And this book, I think, provides you with a nice impression about what's going on in the pilot wave community, because we discuss the Bohm's and the Broglie theory from various perspectives, from a historical perspective, philosophical discussion. We have also paper about extensions of Bohm's theory to relativity and quantum field theory, discussions about non-locality, the meaning of Bell's theorem in the context of Bohm theory, and also application of the theory to quantum chemistry, weak measurements. So I would say that this book not only show a pluralist perspective about what is the pilot wave theory, what is the pilot wave community. It's wrong to think of it as a dead research program or a static one. There are a lot of different views, a lot of different perspectives, and a lot of interesting new results. So I would say this is an invitation to everyone interested in quantum confrontation to give a second chance to the pilot wave theory.
Great. Thank you very much for taking the time to do the interview. I enjoyed it a lot.
Yeah, thank you, Nicholas.
Yeah.